to you. It's up to you. Bishoy, if you don't trust me, if you trust me. So does anyone in the studio audience have any idea of something that a wave would do that a particle wouldn't? Go on then, man. Fast.
Oscillate.
It oscillates, it can go up and down, but so can a particle. You can make a particle go up and down. This is brilliant. Example 2 months. Here's a tower. Sorry?
Particles, they have charges.
They can do, yeah. But you can't charge up a wave? No, you can't. You're right. I mean?
Transferring energy.
Okay. Do you think particles can transfer energy? Absolutely. So they both transfer energy. What would a particle do that a wave doesn't? Or what would a wave do that a particle doesn't in terms of transferring energy? Now, Amir has just hit on exactly what Einstein came up with. What does a wave do when it transfers energy that a particle doesn't do? Or what does a particle do when it transfers energy that a wave doesn't?
Waves carry energy from one place to another, but particle carries the energy itself.
Okay, but can you imagine if I sent a particle from me to you? The energy has been transferred from my hand to your hand. What would happen if I sent a wave from Amir, from myself to Amir?
The wave would get used up, whereas the particle just transfers the energy, it doesn't disappear.
Think about the energy though. The energy has gone from my hand to Amir's hand. So it's been transferred.
When a positive transfers energy, it still retains some, but wave transfers all.
We're talking about giving up all the energy though. It's a specific case. What does a wave do? Imagine I sent a wave from me to Amir.
The wave reflects or refracts.
Okay, we can have all of those things. Does it, a wave can reflect? Can a particle reflect? You throw a bouncy ball on the wall, it comes back again, doesn't it? So reflection, I'm going to leave a space for transferring energy.
Does it get absorbed?
You're kind of getting towards the right answer for this, yeah. But I need a bit more elaboration than that, but you're getting towards the right answer. Reflection, what's refraction? What causes refraction?
When a wave enters a gap or obstacles, the wavefront changes direction.
That's diffraction. But we can have that on the board at the moment. Does diffraction happen to particles or to waves or to both? Only to waves. But electrons diffract. You've seen that, haven't you? What does that tell you about electrons? Mirza?
The wave front behavior.
Absolutely. Electrons can behave like waves. Can you tell me where would refraction go here? No, can you remember what causes refraction, not diffraction?
When it changes from one medium to another.
So what happens?
Changes direction.
Doesn't have to change direction.
changes speed as it passes through medium.
Absolutely. Is that a wave or a particle property?
A wave.
A particle can't change speed when it changes medium.
It's both.
It's both. Think about your car on the road. One side the wheels of that car is a particle. So you've got refraction. Means changing speed. Can we go back to transferring energy? So, sorry, just to make it clear. Phil, can you stop when it gets to 15 minutes? What we at now?
550.
Oh, really? Okay. Getting efficient at this. Does anyone see my cup of coffee? It is. Now, what do you think?
I actually have a question. Is there a difference between transfer and transmission of energy? Or are they just meaning the same thing?
Transfer means to go from one thing to another. Does transmit mean that? Don't. I would always use transfer.
When we say particles, not mass, but waves.
What the waves have? Wavelengths, frequency, all this kind of stuff. But those wavelengths and frequencies correspond to energy. So the energy, if you can remember the video, E equals mc squared, that energy is equivalent to mass. Now this is brilliant that you came up with this to start with. Can you think the difference between how a wave transfers energy and how a particle would? Philip?
Is it when a wave transfers energy, it loses, like it gets smaller? Or when a particle loses energy, it stays the same?
I preferred Matt's thing at the start to that. Say that.
When a wave loses energy, it loses mass, but when a particle loses energy, it loses speed.
Waves don't tend to have mass unless you go on to study physics for a long time.
When a particle does less energy, it can also easily get the mass.
You're kind of saying the same thing as Matt, but it's not precise enough what you're saying.
Wait,
Okay.
what did Matt say?
He said something about
It gets absorbed.
it gets absorbed, but that's not. It's got to be a bit more precise than that answer. Right, I'm going to transfer some energy via a particle to Mirza. He catches it. He's got the energy. What would happen if I transferred energy via a wave to Mirza?
It would be like given.
Yes, that's absolutely correct. What would happen to it? It would get like given, and he does this with his hand. What would happen? Be more precise. Mirza has got it absolutely correct. And between all you three, you've got worked it out, but you've not explained it well enough.
It would, like there would be no energy left, whereas with a particle still has energy and mass.
No, the particle's over at Mirza, it's not moving. Mirza's got the energy.
Is the energy shared between the two? Because it's
Not shared, shared's a bad word. That makes me think I've got some of it and Mirza's got some of it. Mirza gets the energy.
Is with the particle, Mirza gets all the energy at once, but with a wave, he receives it in sections. Like,
That's absolutely brilliant, Phil and Bauer. That's absolutely correct. So, in a wave, you transfer energy and the recipient accumulates the energy. In a particle, he gets it all at once. Does that make sense? So, let me just write that down for a second. So, doesn't have, I'm going to write down slow there, but it doesn't have to be slow, it can happen really quickly. Now, I'm going to use the word that you'd be expected to use for this. Transferred in packets. Transferred in little clumps. Does that make sense? Transferred as little particles of energy. Transferred packets. And those packets are particles of energy. You're not going to lend your friend some paper? That's crazy.
No more paper now.
Oh, but look at the state of his pad anyway, it's crazy. That's rubbish. When Albert Einstein first started looking at the photoelectric effect, what he found was this effect could be explained if the energy was transferred in little packets and not transferred as waves. And